Conservation principles. The most powerful concepts in science are called conservation principles. These allow us to solve problems without worrying too much about the details of a process. We just need to know where it started and where it finished. We just have to take a snapshot of a system initially and finally. By comparing those two snapshots, we can learn a lot. If we're analyzing a traffic light, the only important thing is where it started here, especially if we're driving, and where it ended up here. So we just need to know it started with green and wound up red. Don't care about the electricity in it or if it passed through any other dimensions, just care about the beginning and the starting point. We already showed last unit that in the absence of an outside force, the momentum of a system is conserved. So we had momentum being conserved as it moves through time. It doesn't change. Can we say the same thing for energy? Yes, we can, with the difference. There can be an outside force as long as it doesn't move the system through a displacement, so no work is done. All right, so that's when we had the case here of a block or a car moving like that, and any force that was perpendicular to it did not change the energy of the system. No work was done. So, earlier, we showed how work can change the energy of an open system. But what happens when no work is done? We've hinted at this before, but now we're going to put it in a little more formal basis. We have our work-energy equation. Initial energy plus work equals final energy. If we do zero work, then we have initial energy is final energy. That's the conservation of energy. Like the conservation of momentum, this is a law of the universe. Actually, the real law is a conservation of mass energy. The total mass and energy is conserved, and one can actually transform into the other, but you'll see that in more advanced physics classes. For now, we'll talk about energy being conserved on its own. Energy is neither created or destroyed, and energy can only be transformed from one form to another. An open system, or object, right, if in case the system is just the object, will always have the same amount of energy unless it is acted upon by outside forces doing work. The outside forces will add or remove energy by the work done on the system, as long as, remember we have a restriction here, the system's position has to change. We will use conservation of energy to solve motion problems in Unit 2, Chapter 5, Conservation of Energy.